Good day, viewers. Welcome to another mathematics lesson. I'm your presenter Khalidou Jallow, and in our today's lesson, we are going to discuss properties of triangles. In our previous lesson, we've talked about triangles. Today, we want to see if we find different triangles, how will we be able to classify them under certain groups of triangles. And our discussion is going to be centered on three of them, which are equilateral triangles, isosceles triangles, and scalene triangles. Like I said earlier, there are different types of triangles that we have. So we are going to see some of them, and then we'll see the need why we'll have to give them different names based on their properties. Like for instance, if you have a triangle like this, it is obviously different from a triangle like this. Triangles come in different shapes and size. Looking at comparing, let's say this is triangle A, this other one is B, and this one is C. If you look at triangle A and B, you will see certain difference in them. Like, although they are all triangles because they all have three sides, and also they all have three angles. But what is the main difference between these triangles is the fact that their angles differ. Like for instance, when we look at triangle A, we will know that, like, we'll be able to pinpoint that triangle A has one of its angles equal to 90 degrees. Well, we don't know the value of the other angles, but we know that one of the angles is equal to 90 degrees. Now, when we compare that to the second triangle, you realize that maybe we have this other angle more than 100 degrees or more than 90 degrees. So you will see there is a huge difference when it comes to the angles of the triangles. So based on that, we will categorize these triangles based on the properties that they possess. And in our today's lesson, we'll make sure we'll discuss three types of those ones, which are equilateral triangles, isosceles triangles, and scalene triangles. Again, when we look at the third triangle, which is triangle C, again, you can see that the largest angle of the triangle can be more than 90 degrees. So it is different from the first triangle or triangle A. So based on that fact, you can also have triangles wherein all the angles in the triangle are less than 90 degrees. They are less than 90 degrees. So how do we classify such triangles and so on? So today we are going to center our discussion on that, and we will classify them based on equilateral triangles, isosceles triangles, scalene triangles, and so on. So we look at the first one, which is equilateral triangle. When we see equilateral triangles, or when we come across with triangles, how do we identify equilateral triangles from those sets of triangles? First, we need to look at something that is very key when it comes to equilateral triangles. We said equilateral triangles has all its sides equal and all its angles equal. All the sides of an equilateral triangle, all the sides are equal and all the angles are equal. Now here, regardless of the size of the triangle, whether the triangle is big or small, the only way that we can identify that this triangle is an equilateral triangle is based on the fact that all the sides of the particular triangle must be equal, and all the angles of that given triangle must also be equal. Let me give you a classical example here. Let's say we have a triangle A, B, C. We know that the points A, B, C form this triangle. Another information that we are given is the fact that line CA is equal to line AB, which is also equal to line BC. Then angle A, angle C, and angle B must also be the same. So in order for this triangle to be qualified to be an equilateral triangle, from point A to point B, which is going to be line AB, should be equal to from point B to point C, which is the same thing as line BC, which also should be equal to the point from C to A or from A to C, which is going to be give us line line AC. These three lines should be equal for the triangle to be referred to as an equilateral triangle. Also, not only about the triangles, but the angles itself. Angle A, angle B, angle C, they should all be equal, and they should all be equal to 60 degrees. Because we know that the sum of angles in every triangle is equal to 180 degrees. So if we have a triangle that all the angles are equal, it means we will have to divide 180 by 3. And 180 divided 3 will give us 60 degrees. So in an equilateral triangle, all the angles are equal, and all the angles are equal to 60 degrees. Like for the case of the example that we have here, we can say that angle A is equal to angle B, which is also equal to angle C, and all of those angles are equal to 60 degrees. That is the concept of equilateral triangles. And no matter how the triangle is given to you, you should be able to know if they are equilateral triangle, judging based on those two properties. Remember we said the properties are the equilateral triangle, all the sides are equal and all the angles are equal. Let's say you are given a triangle. It is just a plain triangle without no marks on it to indicate that the sides are equal. So since the triangle, the sides are straight lines, you can simply use a ruler to measure the sides. When you find out that all the sides are equal, then you can conclude that it is an equilateral triangle. If triangle is labeled as P, Q, and R, and you measure the distance from P to Q, and realize that the line PQ is equal to the line QR, and that is also equal to the line PR, then you can conclude, based on that, you can conclude that the triangle is an equilateral triangle. So another way also to find out if a given triangle rather is an equilateral triangle is by measuring the angles. When you have a protractor, you can also measure the angles, and if you realize that all the angles are equal to 60 degrees, then you can also conclude that that triangle is an equilateral triangle. So far, all what we need to know about equilateral triangles, that all the sides are equal and all the angles are equal and are also equal to 60 degrees. Then we look at another one. Here we have isosceles triangles. Now, what are isosceles triangles? We've talked about equilateral triangles. That is when all the sides of the triangle are equal and all the angles are equal. Now, how about isosceles triangles? What do you know about them? What can we say about isosceles triangles? Here we have isosceles triangles are triangles that have two equal sides. They are triangles that have two equal sides. And the base angles of the equal sides are equal. The base angles of the equal sides are equal. Now, what do we mean by that? What do you mean by the base angles of the equal sides are equal? Let me explain the first one first. That is, they have two equal sides. Whenever you are giving a triangle, or whenever you come across a triangle, and you realize that two of the three sides of that given triangle are equal, that means that that particular triangle is an isosceles triangle. Like for instance, if you have a triangle here, let's say this triangle is X, Y, and Z. Now triangle X, Y, and Z, it has three sides. That is why it is a triangle. Now how do you know that it is an isosceles triangle? Is when you find out that two of the sides are equal. Like for instance, if we come to realize that line XY is equal to line XZ, that is, this line here and this other line here are equal. In such instances, we can conclude that that triangle is an isosceles triangle. Remember, if the third line, that is line YZ, is also equal to the other ones, it means it is no more an isosceles triangle. Instead, it is an equilateral triangle. So the key thing that we need to understand here is the fact that two of the lines must be equal, not three, because if all the three lines are equal, then it will give us another category of triangles, which is the equilateral triangle. So it can also come in different shapes and size. Like you can have the isosceles triangle like this, wherein we can have point A here, when we have point B here, and point C there. What is the most important thing here is that the line AB is equal to line AC. If these two lines are equal, then you can conclude that it is an isosceles triangle. The second thing that we need to consider here is the base angles of the equal sides are equal. Base angle of the equal sides are equal. Like in the one that I drew here, that is triangle ABC, we said AB is equal to BC. AB is equal to AC rather. If you establish that AB is equal to AC, then you can conclude that the angle at the base of the two lines are equal. That is angle B and angle C. In this triangle here that we are given, let's assume it is labeled as P, Q, and R. Then we will call it triangle PQR. From the diagram, we can see that line PQ is equal to line PR. That is, PQ is equal to PR. Now, what does that tell us about the base angles? That is, the angles that are formed on line RQ. What we can say about the base angles is that they are equal because the angles, the lines that are formed from P to Q and from P to R are all equal. So therefore, the base angles are equal. We look at the third one here. Let's say this other one is KR and M. Triangle KR and M. Again here, if we observe, you realize that, or it is given to us that line MK is equal to line MR. Once we are able to establish that line MK is equal to line MR, then therefore we can conclude that the base angles of line MK and MR are also equal. So since the base angle of line MK and MR are equal, then we can also classify that triangle as an isosceles triangle. So no matter the size of the triangle, whenever you establish that the two sides are equal, then you can conclude that it is an isosceles triangle. That is key in identifying isosceles triangles. Two of the sides are equal, and the base angle of those two sides are also equal. So probably you may see a triangle like this. Let the idea of base don't take you along. You can have a triangle like this, and here may be point A, and you are told that here is point C, and we have point B here. So we are told that line AC is equal to line BC. So the base that we are referring to here is the base angle of the equal sides. These two sides that are equal, their base angles are the ones that are equal. So do not be confused about the idea of base here, but we are actually referring to the base angle of the equal sides that are equal. So in this case here, we are referring to angle B and angle C respectively. They are the ones that are equal. Then we move on. That is all for isosceles triangles. I hope if you come across triangles and you are able to measure that two of the sides are equal, you can conclude that such triangles are isosceles triangles, and the base angles of those triangles are also equal. We look at the third one, which is scalene triangles. Now, what are scalene triangles? What do we know about them? If you come across triangles, how do we establish that this triangle is a scalene triangle? Well, scalene triangles are triangles that has none of its sides equal and none of its angles equal. They have none of their sides equal and none of their angles equal. So far, I think they are the triangles that can be easily identified, because once you can establish that the sides are not equal, none of the sides are equal, and then that will obviously mean that none of the angles are equal. So you can conclude that it is a scalene triangle. It is different from the equilateral triangle, where we have all the sides equal. All the sides are equal. It is also different from the isosceles triangle, where we have two of the sides are equal. Now we come to the scalene triangle, where none of the sides are equal. So when you come across a triangle, being it is labeled or not labeled, once you are able to measure the three sides of that given triangle, once you are able to measure the three sides of that given triangle, let's say this triangle is triangle X, we have triangle X, Y, and Z. We have triangle X, Y, and Z. And we are asked to determine what type of triangle is this, based on equilateral, isosceles, and scalene triangles. So one thing we can do, we can measure the sides. Since the sides are straight lines, we can use a ruler to measure the sides. Let's assume, based on assumption, we measure line XY. When we measure line XY, we realize that it is equal to 13 centimeters. Then we decide to measure line YZ, and we find out that line YZ is equal to 5 centimeters. From there, we measure line XZ, and line XZ is equal to 8 centimeters. Now, what does this tell us about the triangle? When we look at it keenly, we will see that none of the three sides are equal. So since none of the three sides are equal, we can conclude from that point that that particular triangle is a scalene triangle. You can also use the idea of measuring the angles. If you have the protractor and you think you are comfortable with measuring the angles to determine what type of triangle it is, you can still do that. You can measure angle Z, angle Y, and angle X. So once you establish that angle Z is not equal to angle Y, which is also not equal to angle X, which is also not equal to angle X, you can conclude from this point that that particular triangle is a scalene triangle. So far we've discussed these three types of triangle. I will take you through, starting from equilateral triangles. We said equilateral triangles, there are two properties that we need to see in them so that they can be identified as equilateral triangles. And such properties are: all the angles must be equal and all the sides must be equal. Also, once you realize that all the angles are equal to 60 degrees, you can conclude that it is an equilateral triangle. Sometimes, if the triangles are given to you, you'll be seeing these marks on them. Once you realize that all the marks are there, even though the triangle is not labeled, once you see that it is simply telling you that this line here is equal to this other line, which is also equal to this line. So at that juncture, you can conclude that that particular triangle is an equilateral triangle. But what is key here is the fact that all the sides are equal and all the angles are equal. Then the isosceles triangle is wherein we have two of the sides equal. As we said earlier, if two of the sides are equal, then the base of the equal sides are also equal. The base angle of the equal sides are also equal. Now here also we need to consider the fact that two of the angles must be equal for it to be qualified to be called an isosceles triangle. So you must have two of the sides equal, and if two of the sides are equal, the base angle of the equal sides are also going to be equal. So in such cases, when we establish both of these conditions or one of the conditions is true, which will require the second condition to be true as well, then you can conclude that it is an isosceles triangle. Then the third one is the situation wherein we have none of the sides equal. Since none of the sides are equal, none of them are equal, it is obvious that none of the angles are also going to be equal. So if you are given a triangle, even if it is not labeled, and you are able to measure all the three sides of that triangle, and you realize that none of those sides are equal, you can conclude that that particular triangle is a scalene triangle. If you are comfortable with measuring the angles instead of the sides, and you use probably a protractor to measure the angles, and you come to realize that none of those angles are also equal in that particular triangle, then you can also conclude that that particular triangle is a scalene triangle. So I hope when we come across triangles and we are able to examine their properties, and one luckily may fall under these properties, you can be able to tell what type of triangle it is. Now we look at this question here. It's on matching. It said match the following plane shapes to their corresponding names. The first one have been already done for you, so we are going to match them. Remember, in our previous lesson we've done squares and rectangles, so they may likely appear here. But then we have 5 of them. The names are isosceles triangles, scalene triangles, equilateral triangle, square, and rectangle. So we are going to match them. The first one has already been answered for us. We have the shape here, which is a rectangle, and we define, if you can remember from the previous lesson, we define a rectangle as a plane shape that have 4 sides, and the opposite sides are equal and they are also parallel to each other. Then the second name that we have is scalene triangle. Earlier in a lesson we've discussed scalene triangles, and what did we say about them? We said scalene triangles are triangles that that none of the sides are equal and none of the angles are equal. So looking at the diagram, we look at them one after the other. If you look at the picture, this other picture here, you see that it's a triangle, yes, but all the three sides are ticked. So that is telling us that all the three sides are equal. And what we know about scalene triangles is the fact that none of the sides are equal. So obviously that one is out of it. Then we look at the plane shape underneath. It is a square because we can see that all the sides are equal. And what we know about squares, they are plane shapes that have 4 equal sides and 4 angles that are all equal. And that is the character that we are seeing here. So obviously it is not a scalene triangle. Then we look at the fourth one, which is a triangle. And if you look at it closely, we realize that none of the 3 sides are equal because it is already labeled on the triangle. We have the triangle like that, and we are told that this side is the greatest side, followed by this other side, that is the baseline, followed by the other side. So once you see this form of labeling, it is simply telling you that if this triangle is labeled as ABC, line AB is the greatest line, it is the longest line, then followed by line BC, and then followed by line AC. So in this case, we can conclude that this triangle is a scalene triangle. So in order to match the scalene triangle to the right image, we'll have to have this triangle here, because it is the one that is a scalene triangle. So then we look at equilateral triangles. Earlier we've talked about equilateral triangles, and what did we say about them? We said equilateral triangles are triangles that all their sides are equal. All the 3 sides are equal, and all the angles are also equal. So looking at the plane shapes that we have here, which one of them will qualify to be called an equilateral triangle? Remember, we need to look for a specific thing. And that particular thing is the sides being equal, and or, I meant to say, and the angles equal. You cannot have one of the situations. Once all the sides are equal, then it means all the angles are equal. So looking at the images as well, we see that this one that falls under C has all the sides ticked once. So that obviously means that all the sides are equal. A replica of it is what we have here. If this triangle is to be labeled, let's say P, Q, and R, what this simply means is that line QR is equal to line PR, which is also equal to line QP rather. So if all the 3 lines are equal, then it is referred to as an equilateral triangle. So there our matching will be like this. That will be the equilateral triangle. From there, we look at the fourth one, which is a square. Yesterday we discussed squares. Now I want to know which one among these plane shapes is a square. And that what did we say about squares? We said squares are plane shapes that have 4 equal sides. There are 4 equal sides, and they also have 4 equal angles. So if you are going to draw that, it means a square will look like this. This side and this side must be equal, which is also going to be equal to the 3rd side, and is going to be equal to the 4th side. So if this happens, it means all the angles are also equal, and consequently they are all equal to 90 degrees. So let's look at the images here and see which one will qualify to be called a square. In such instances, the shape should have all its sides equal and all its angles equal. So we realize that the shape under D will be qualified for it, because we can see that all the sides are equal. Even without measuring, just by looking, you will come to realize that all the sides are equal. So that one will be qualified to be called a square. Then we look at the last one. Obviously here there is no much work to do, because the one pending, we have one shape pending and we have one name of the shape pending. But without that, we will still talk about the name and what are the characters of that shape, so that we can examine to see if the shape given is actually the one that we are looking for. What we have there is an isosceles triangle. And what did we say about isosceles triangles? We said isosceles triangles are triangles that have two of their sides equal, and the base angle of the equal sides are also equal. Technically, this is telling us that when you have a shape like that, and let's say it is labeled as E, F, and G, and we are told that line EF is equal to line EG. This simply means that this triangle is an isosceles triangle because two of the lines are equal. And if two of these lines are equal, it means the base angle of the two equal lines are also equal. That is, the angle formed at point G and the angle formed at point F. So let's look at the table again and look at the figure that we are left with and find out if it has the same characters with an equilateral, sorry, I meant to say isosceles triangle. Okay, well, if you look at the shape carefully, you realize that it has two of its sides equal. And that technically means that the base angle of the two equal sides are also equal. So then we can conclude that the shape that we are having here is an isosceles triangle. So we can go ahead and mark that. That is the end of that slide. I hope if you are given an exercise like this, you'll be able to critically look at the shapes so that you can determine where do they fall, whether it is going to be an isosceles triangle, a scalene triangle, an equilateral triangle, a square, or a rectangle. Again, we have another table. It says complete the table below. We have from A to E. We are given the shapes as rectangle, isosceles triangle, equilateral triangle, squares, and scalene triangles. We are asked to numbers of equal sides. That is, if we have such shapes, plane shapes, we want to know the number of equal sides that they have and the number of equal angles that they have. So I will have to draw all these angles when we are dealing with them so that we can establish the number of equal sides that they have and the number of equal angles that they have. We will start with a rectangle. We said a rectangle is a plane shape that has four sides and the opposite sides are equal and they are also parallel. In this case, if you have a rectangle like this, since the opposite sides are equal, it means this side here and the baseline here are equal. And this other side is equal to this other side. So this will give us a rectangle as we discussed in the previous lesson. Now, we want to know how many equal sides do they have and how many equal angles do they have. Do it have rather. So since this side and this other side, the base one, they are equal, and the ones on the sides are also equal, then we can say that it has two equal sides. So a rectangle has two equal sides. The one on the left and the right are equal, and the one on top and on the base are also equal. So they have two equal sides. Now, how many equal angles does it have? Well, you will see that the sides, they meet at a point, and the angle that they form is equal to 90 degrees. So all the angles that are formed in a rectangle are all equal to 90 degrees. So in this rectangle, how many angles do we have there that are equal to 90 degrees? Obviously, they are all equal to 90 degrees, but how much are they? If you confirm that we have 1, 2, 3, 4. We have 4 angles that are equal in the rectangle. So the number of equal angles are equal to 4. From there, we move to an isosceles triangle. Now, what can we say about the isosceles triangle, which has been a center of discussion in our today's lesson? We want to know how many equal sides does it have, and how many angles, equal angles does it have. Again, we are going to draw the isosceles triangle, and we know that 2 of its sides are equal. That is, by definition, 2 of the sides must be equal for it to be referred to as an isosceles triangle. So if you are to count how many equal sides does it have, obviously it's going to be 2 equal sides. And also, from the definition of isosceles triangles, we also know that the base angle of the equal sides are also equal. So it means here the base angle of these 2 equal sides are also equal. So if we are talking about equal angles in an isosceles triangle, we know that there are 2 angles that are equal in an isosceles triangle. So the angles that are equal are also equal to 2. Then we move to the third one, which is an equilateral triangle. Now, what can we say about the equilateral triangle, and how many equal sides does it have, and how many equal angles does it have? As we talked about earlier, equilateral triangles are triangles that have all their sides equal. They have all the 3 sides equal. If this triangle is to be P, Q, and R, we are simply saying that line RQ is equal to line QR, which is also equal to line RP. So it means technically all the sides are equal. So since all the sides are equal and it has 3 sides, then on our table our answer is going to be 3 under the column number of equal sides. And also in the definition of equilateral triangles, we said all the angles are equal there, and they are all equal to 60 degrees. So it means the angles that is formed at point R, point Q, and point P, they are all equal. So how many angles do we have there that are equal? They are 1, 2, 3. They have 3 equal angles. Then we move to the fourth one, which is a square. Again, we've discussed squares in our previous lesson. We define squares as plane shapes that have all their sides equal and all their angle equal. Of course, they are 4-sided figures wherein all the sides are equal. So the number of sides that it has are 1, 2, 3, 4, and the number of equal sides that it has are 1, 2, 3, 4. So it has 4 sides, and all the sides are equal. It means all the number of equal sides are also equal to 4. Then from there, we talk about the equal angles. Since it is a square and the lines meet at a point where they form 90 degrees, that means it has 4 angles. And since each angle there is equal to 90 degrees, it means all the angles are equal. And if you confirm how many angles are there, we have 1, 2, 3, 4. There are 4 angles. So the number of equal angles is equal to 4. And finally, we look at scalene triangles. We've talked about scalene triangles and what can we conclude about them. By definition, we said scalene triangles are triangles that none of the sides are equal and none of the angles are equal. I think just going through the definition, we can conclude by answering all the questions. What we are told here that is none of these angles are equal and none of the sides are equal. There is one side that is longer than all of them, followed by the other one, and then we have the smaller side. So in this case, we cannot talk about equality because none of the sides are equal and none of the angles are equal. So the number of equal sides is 0 and the number of equal angles is also 0. So I hope if you are given this kind of exercise, you'll be able to analyze them individually to determine the number of equal sides that they have and also the number of equal angles that they have. That is all what we have in this lesson. I thank you all for your attention, but before going, I want you to look at your homework, and you'll have to see exercise 1.3 and 1.4 of the geometry worksheet to solve the questions. I thank you all for your attention.